The owner of this vintage Supro guitar amplifier was told that the output transformer was bad in it. If he's right, it'll be an expensive fix, but in my experience, the obvious problem is rarely the real one. Let's see if the transformer is bad or if something else is killing the tone. Here I'm applying 317 millivolts RMS to the secondary and measuring 3.87 volts RMS across the primary plate to plate. That gives us a turn ratio of about 12.2 to 1. Squaring that and multiplying by the 8 ohm secondary load gives us a reflective primary impedance of only about 1.2 kilo ohms plate to plate. For a push-pull 6L6 amp, that's much lower than expected, which strongly suggests the output transformer does have a problem, but let's continue testing to be sure. All right, let's measure the resistance of the output transformer. I've got it tied to the secondary, and we got 0.74 ohms. That's usual. Then we go from plate to plate, 151 ohms. Plate to center tap, 71, and to the other plate, 80. Now let's check it for any leakage between the primary and secondary. Oh, that ain't good. 114 kilo ohms. And that's almost a meg, 800 K. So that explains why our oscilloscope reading was off. Let's unsolder everything and get it all out in the open and test it again. I'm beginning to suspect our problem may be in this power supply somebody's hacked up. Now we got all the leads disconnected, let's test it again. Connect one end to the secondary. We come over here and connect to the plate. Okay. One's okay. One's okay. 5. Measure from plate to plate. That's plate to center tap. Plate to center tap. That looks healthy. I don't see any cross leakage between the primary and secondary. Where was we getting our leakage from? Maybe it was from the capacitor. Check back over here on this side. Yep. You have a feeling this first filter capacitor is bad in it, and I believe I know why it is too, looking at the power supply. And judging by the old crusty electrical tape, you can tell somebody's already changed it out one time. And they used a 480 volt center tap transformer with a bridge rectifier, which gives you about 679 volts. That's way too high for this 450 volt capacitor. Now we have the transformer set back up with all the wires out of circuit, and now our reading looks much better. Now let's go back and measure our transformer again out of circuit and see what we have. Before we had 3.7 volts, now we have 7.61. If we divide that by the input voltage, we get the turns ratio 24.39. Then if we square 24.39, we get the impedance ratio of 594.9. Then if we multiply that by the speaker impedance, which is 8 ohms, we get 4,759 ohms, which is close to the 5K that we need for a push-pull 6L6. Watch this previous video I made on bucking transformers to see how we're going to rebuild this power supply. I'm going to build this power supply back in the Supro, and I'm going to use this method and see how it works in the amplifier itself. That's coming up in our next video. Thank you for watching.